This is a review of Chapter 6. We're going to do 6.1 through 6.4. The first problem here in 6.1, to solve this triangle, we can start by looking at the missing angle here in the top. We can do 180 minus the known angles to give us the missing, which is 105. From there, we can set up the law of sines. Since we're trying to find side lengths, it makes sense to have the side lengths on the top. And we can write the ratios 10 over sine 105 is equal to A over sine 35 or B over sine 40. And we just pick two of these and set them up as a proportion and cross multiply. So for this part, I could take both sides multiplied by sine 35, which gives me this. And if I put that in my calculator, my A value is going to be 5.9. My angle here was 105 degrees. To find B, I'll use the other equation, which means I'll take 10 sine 40 divided by sine 105. This gives me 6.7. And I've solved the triangle. Now, just to make it easy, I set up the triangle the exact same way in terms of A, B, and C and where everything was, and then I just matched the ones that we already had. So with this one, we're going to start with the 58 and the 4.5 because those are known, and I can use that ratio of sine 58 divided by 4.5. And since I'm trying to find angles, I'm going to put the sine on the top this time. And this allows me to multiply both sides by 12.8, and I can take the sine inverse of all of this, I guess. And that gives me my answer. And when I do so, I get a domain error, so it looks like maybe the problem's a little messed up. I think that's probably because if you looked at a side length of 4.5 and this angle, and then we tripled the side length, this angle across from it is going to have to be much bigger, and we're going to run out of space. We won't have enough angles. So why don't we switch these two? And if we do that, and take the sine inverse, we get that angle B is 17.3 degrees. And by taking 180 minus the 58 and minus the 17.3, we get that this angle is 104.7 degrees. So let's set up this other ratio, and to find C, we can just do it like this. We'll multiply both sides by sine of 104.7, canceling this out. And whatever we get here is our C value. It looks like we get 14.6. So as written, this problem did not work. You had to switch the A and the B value. Sorry about that. So there's a couple different area formulas in 6.1. For this one, we looked for the one that had sine B, since that's the angle we were given, and we just plug these in directly. And if we plug that in correctly, we get 58.7. And we don't have a unit, so I'll just say units squared, because it's area. Here's our diagram. We have point A over here, and we have point B. And you can see that as you get closer to the plane, the angle gets steeper. So that's how I drew my angles of elevation. And they want to know the altitude of the plane. So there's a couple different ways you could do this probably, but let's say that I want to find this one first. So what I did is, based on that angle of elevation of 72, I filled in its supplement, 108 on this side. And that means that this top angle here is 17, and we're going to use the law of sines based on the 2.2 and the 17, and the 55 and whatever this value is. So if I set up that ratio, it's 2.2, which is across from the 17 degree angle, and then an unknown length, which is across from the 55 degree angle. And if I find that, I get that A is equal to 6.2. So let's think about this next triangle here. I have a 90 degree, and I have figured out that this is 6.2. So the altitude is unknown. We're going to just call it altitude. And across from that is this angle 72. And then the green part in the diagram, which I discovered to be 6.2 using the ratios from the left triangle, is across from a 90-degree angle, because that's how you find altitude. What we discover is that this is going to be 5.9. And what do we have for units? Anything? Miles. So it's 5.9 miles. 6.2, here we have the law of cosines. Because we're finding one of the angles, let's say A, we can plug it in like this. We plug in the values like this, and we can take the cosine inverse of what turns out to be 1/2. Now, if you recognize this, you'll know that it's 60 degrees. You could potentially recognize that from the unit circle. So we can write 60 over here. So let's use one of the other forms for law of cosines to find the second angle, and then we can use the fact that they all add up to 180 to find the third. Well, I guess actually it might be faster to use law of sines at this point. So you could do that, but it might be faster just to use this ratio instead of using that formula from the get-go. It's a little bit shorter. So we can figure out sine b by multiplying both by 3 and taking the sine inverse of 3 sine 60 over 7. And if you do that for angle B, you get 21.8. We already discovered angle A was 60 degrees, which means that if you subtract them, you get 98.2 for the third one. So we can use one of the alternate forms of the law of cosines. They call this a two sides and an included angle. You notice how 92 degrees is right between 11 and 10. So if you set up your diagram like this is how we can solve what a squared is. So if you plug in those values and you use your calculator, and the last step you're going to take the square root, you can find that our distance there is going to be 15.1. And I'd probably use law of sines to figure out these other two, and I'm rounding here. Well, I guess I didn't round yet in the calculator, so I could have the exact value here. I could say 10 times sine 92 divided by 15.1, and I take the sine inverse of that. And this other angle here, C, is going to be about 41.4 degrees. 180 minus 92 minus 41.4 gives me 46.6. Might be slightly different depending on how you rounded your A value. This next one, we're going to plug in these values. Remember, to find our S, we have to take S is equal to A plus B plus C divided by 2. So if you add all these up, 70 plus 60 plus 55, and you divide that by 2, you get that S is equal to 92.5. We're going to plug that in, so we have the square root of 92.5 times the difference between 92.5 and these 3 points. Put this all in your calculator though, and you get 1,592.6 units squared, because it's area. To find the component form, given two vectors here in 6.3, you're going to subtract x minus x and y minus y to get your new values here. So 8 minus a negative 9 gives you 17. Negative 12 minus a negative 4 gives you negative 8. That is your component form, 17, negative 8. To find the magnitude, you're going to take that component form and treat it like the Pythagorean theorem. So think about here, you are in the coordinate plane. There's 8, negative 12, thereabouts, and then you're heading this way. So how far did you go to get there? Well, it looks like we went over 17, and this value is going to be 8. I'm sorry, I went the other direction. I went from initial to there. So that's why it's going down. I guess I could draw that diagram like this. You start here, you go 17 to the right, you go 8 down, and you have ended up at your initial point. So think of it like Pythagorean theorem. That magnitude is going to be 18.8. The only way you might mess it up is if you don't put the negative inside parentheses and your calculator does it wrong. Next up, if you want to add u and v, you can think of it as just adding the x and the y's together, like x plus x and y plus y. So u plus v would simply be a matter of negative 2 plus a negative 3, which gives you negative 5. If you wanted to write it in that format, you could. Negative 4 plus 7 would be the other, which is negative 3. So the alternate form would be minus 5i minus 3j. That should be a plus 3j, excuse me. For the second part, where they have you take 2u minus 3v, this is our u, and we are doubling it. And this is our v, and we are taking this times a negative 3. So these are the 2 points, and if we want to put them together then, we can take the negative 4 from over here and the positive 12 from over here and put them together. And that gives us 8u, and then we can do the same thing with the negative 6 from here, 2 times negative 3, and the negative 21 from there, and if we put those together, we get minus 27. Sorry, this should be I and a j. 8i minus 27j, and we can also write it as 8 negative 27. Both of those will work. So if we want to find the component form of this vector, think about, let me erase some of this extra marks here, sorry about that. Think about this as a triangle that you go left 4 and down 3, and this is your point. Normally, if you think about a Pythagorean triple, that hypotenuse would be 5. But we're not traveling the full 5. We are going 3, and then we're stopping. So we can think of our magnitude as 3 out of 5, 3/5 of what the original would be. So we take that vector, negative 4, negative 3, and we multiply by 3/5, and we get negative 12/5 and negative 9/5. Similar thing going on here, we have a magnitude and we have a direction. So if you think about that as being 60 degrees, we actually have a 30, 60, 90 triangle. And across from the 90 here is the 4 root 3, which means that across from the 30 is half of that, 2 root 3. And across from the 60 is 2 root 3 times root 3, which is where you get 2 times 3, or 6. So now it's like this is my x-coordinate and this is my y-coordinate, which is how I can write it over here in component form. If you didn't recognize the 30, 60, 90 shortcut, you could have used SOHCAHTOA trigonometry to find out these side lengths. So this one, we have 75 pounds, 100 pounds, and 125 pounds acting on an object at different angles, respectively. So if you think about the unit circle, you can actually figure out what these values are. 30, 45, and 120 are all on there. And if you don't want to do that, you can just leave them in terms of cosine and sine, which is fine too. So this is what we add together. And maybe an easier way to write it, the way we wrote it when we did it in the notes, would be 75 cosine 30, that's the x-coordinate here, plus 100 cosine 45, plus 125 cosine 120. And all of this is going to give me my x-coordinate. And then the other side would be to take 75 sine 30 plus 100 sine 45 plus 125 sine 120. So I just split that into my x and my y, and if I do that correctly, I get 73.2 and 216.5. If I want to find the theta, the angle, I can take the tangent inverse of my y over my x, so 216.5 over 73.2, and that'll give me my angle, 71.3 degrees. If I want to find the actual magnitude of x plus y plus z, I can just take the square root of 73.2 squared plus 216.5 squared, which gives me about 228.5 pounds of force in this direction, 71.3 degrees. 6.4 dot products. We take the 7 and the 3, we multiply them, the x-coordinates. We take the negative 4 and the 2, we multiply them. So we have 21 and negative 8. We put them together, we get 13. Easy breezy. Similar thing here, but a slightly different look. Notice it's not in i's and j's, but it's still the same thing. So we take 3 times 4, and we add together 2 times 0, and we get a total of 12. This one happens in layers. First we do this part, negative 2 times whatever w is, and we get this. And if we're going to multiply that by u, think about dot product again. So you multiply the x-coordinate, you add them together. You multiply the y-coordinates, you add them together. I see I made a small mistake here. I wrote 27 when I should have wrote 2. I saw my bracket as a 7, so we'll put 2 times 3 there. That changes things a little bit. And this is now a 6, so the answer is -6. Which means if I scale that, I'm going to end up with 6, -24 as my resulting vector. To find the angle between these two vectors, we're going to use that cosine theta is equal to uv over the magnitude of u times the magnitude of v formula. So to figure out the top one, that's just dot product, 2 times 6 plus -1 times 4. That's -16. And on the bottom, we take the magnitude of u, which is the square root of 5, and the magnitude of v, which is the square root of 52. We can combine them into the square root of 260. If I think about a prime factorization tree of 260, well, that breaks into 26 and 10, which breaks into 13 and 2, and 2 and 5. So I'm going to use these factors, 4 times 65, to simplify my square root a little bit. That brings me 2 root 65 on the bottom. And if I want to rationalize the denominator, I bring it to the top, and this is my final answer.